React Native developers, welcome to this course on declarative gestures and animations with Reanimated 2. As you know already, the key to success when writing gestures and animations is to avoid frame drops. And in the context of React Native, this means that we need to run all of our gestures and animations on the UI thread. If we use the default gestures and animation APIs from React Native, we rely on communication between the UI thread and the JavaScript thread. This communication is asynchronous, meaning that we cannot guarantee that the response will come back within 16 milliseconds, especially on low-end devices. Plus, the JavaScript thread might be busy doing some renderings, processing an HTTP request, you name it. And so the strategy is to declare all of our gestures and animations beforehand, and the UI thread can compute each animation frame without relying on the JavaScript thread. This means that even if the JavaScript thread is extremely busy, your gestures and animations will be smooth as butter, even on low-end devices. And the way we applied this strategy with Reanimated 1 is that Reanimated 1 is providing us with a domain-specific language to declare from JavaScript these gestures and animations. That worked pretty well. We were able to build really smooth and really cool gestures and animations using this technique. It had a couple of issues. The first one is that the barrier to entry was really high. You had really to get into this declarative mindset. So you were writing JavaScript code, but in fact, you were using a domain-specific language to declare these gestures and animations. So the barrier to entry was quite high. You really had to spend a lot of time to get into this mindset. And it took us a lot of time to be really comfortable using this domain-specific language. The second issue is that, so this DSL turned out to be quite powerful. If you look at the Can It Be Done in React Native YouTube series, we have built really cool user interactions using such a technique. But it was not as powerful as it could be. So a common use case was with graph user interactions where we need to format numbers and dates. So for such a use case, for instance, we had to cross the bridge. So in order to use JavaScript to format dates and values. And there were a lot of mathematical tools that we had to rewrite from JavaScript to this domain-specific language so we can use them in our gestures and animations. And for simple mathematical tools, it was okay. For more complex tools, it was getting quite hairy. And I should know because I rewrote some of these tools, part of the React Native Redash library. And last but not least, one issue with Reanimated 1 is that this declaration of gestures and animations from JavaScript to the UI thread had a cost. And this performance cost of doing the declaration beforehand was substantial. And because this declaration cost was not only substantial and especially on low-end devices, you also had to take care that you don't redeclare nodes, gestures and animations more than needed. For instance, when having a re-render in a component. So you had to do memoization of your animation nodes. And that process was super hairy. In fact, in later versions of Reanimated 1, there were the proc animation node that allows us to pre-declare gestures and animations even before a first React render. And you had to be extremely careful using this proc node. In fact, even in the built-in functions from the Redash library, the proc node introduced bugs because it was used in a way that was not semantically correct. And when the proc node was introduced, functions like diff clamp stopped working properly in a later version of Reanimated 1. So that was quite a hairy process. So overall, the Reanimated 1 was quite difficult to harness. In Reanimated 2, the mindset has been shifted. In Reanimated 1, so we knew that this is the goal, to run gestures and animations entirely on the UI thread, and they work up a solution that allows us to declare our gestures and animations. In Reanimated 2, the team at Software Mention went the other way around. They asked, how would it look like if we had no constraints in writing gestures and animations in React Native, and started from there. And they introduced the concept of animation worklets, which is inspired from a concept in the same name on the web. And animation worklets are JavaScript functions that run entirely in the UI thread in an isolated context. Now, in this lesson, I would like to show you animation worklets, how they can interact with each other and how they can interact with your React code on the JavaScript thread. They have many interesting ways to communicate with your React code. And I would like to show you shared values. Shared values are the new animation values in Reanimated 2. These values exist both on the UI thread and on the JavaScript thread, hence the name shared values. And I wrote down this quick table. So in Reanimated 1, we had this declarative domain-specific language. In Reanimated 2, we're going to write JavaScript code directly. So in Reanimated 1, we had the condition animation node, and we were writing our conditions, and we had the block animation node and so on, and we had the set animation node. In JavaScript, we're going to write if, else, use equal operators, and so on. In Reanimated 1, one of the issue was the declarations beforehand were quite slow, or at least had a substantial performance cost, and we had to take care of memorization and so on. In Reanimated 2, they are blazing fast. The animation values in Reanimated 1 could be only numbers of strings. In Reanimated 2, they can be of any type. It can be an object, an array, you name it. And the animation values existed only on the UI thread. In Reanimated 2, we use shared animation values, which are available both on the UI and JavaScript thread. And we're going to have a look at what that means. In Reanimated 1, we could use the call animation node to call back asynchronously to the JavaScript thread, which was super convenient. And in Reanimated 2, we have the same capability available, of course. And the way it's going to work is that we are going to invoke the function directly. So let's have a look in the code. So here I have a project with Reanimated 2. And you see here, we can declare JavaScript functions to be an animation worklet by using the worklet directive. This tells Babel to send this function to be compiled and executed on the UI thread. And they have a couple of interesting ways to interact with the JavaScript code of our main JavaScript thread. So the first thing we're going to do is to create a shared animation values. And we want to display some text in our UI. So I'm going to create a shared animation value called text. And the default value is an empty string. And now we're going to create a worklet functions to say hello. So let me create a worklet. So say hello. And maybe we can pass some parameter from, so we can declare the functions to be a worklet. And maybe here we're just going to do a console log and we say hello from. And we can invoke these worklets from the JavaScript thread, and we can pass parameters to the worklet. So that's the first way they can communicate. Worklets can communicate with the JavaScript code. So I can do onPress. And we're going to use a function called run on UI, pass the function, say hello, and pass the parameters we want to give to the function. So here, I can write beautiful Zurich, Switzerland. Now, let's have a look. So if I say hello, you see here, hello from beautiful Zurich, Switzerland. Now I can pass the animation value as parameter and write the text within the animation value. So here I have the text. And we can set, so the animation value can be, is accessible through dot value. So we can use dot value to read the value or to set the value. You can just assign it here. And now we can just display the animation value using a component called retext. So retext is a helper component which is part of the Redash library, where we use an animated text input to display text values which come from animation values. So the same way we were doing this in V1. So text equals text.value. Let's have a look. This is not working. I need to pass text. So this works now. And so that's the first property of worklets. You can pass parameters from the JavaScript thread. They can also directly access functions, constants from the JavaScript thread. So here, if I do platform.os, which is code that comes from the main JavaScript bundle, since it's a constant, I can access it directly in the worklet. And so that's the second way worklets can communicate with the JavaScript thread. So first, they can receive parameters. They can access constants from the JavaScript bundle. They can invoke other worklets. So here I have the format datetime function, which I can call directly, and I can pass new date. So you see here it works. What I like about this example is that you see here we have an animation value, and we can use JavaScript to format the datetime, which is going to be super convenient, and that's something we couldn't do in Reanimated 1. And then they can invoke functions from the JavaScript thread, but this will be done asynchronously. So let's say I have a function here called foo, and I return a string value, word, for instance. Or no, let's say I do alert. I can invoke this function from my worklet, but this function will be invoked asynchronously. So it's equivalent to the call animation node in Reanimated V1. So you see, it works seamlessly, But now if I were to return the string value, and maybe log it, you should see that result is undefined because this is done asynchronously. So in reanimated 1, the difficulty was really to get in the declarative mindset. Here, things are much simpler, but where the difficulty might lie sometimes is that since it feels that it's all JavaScript and it's all the same thing, we forget sometimes that we have to be careful. Here, if I invoke foo, it's an asynchronous call. And, while these worklets feel like they're just part of your code, they really run in an isolated context, a little bit like OpenGL shaders. It's very similar conceptually to OpenGL shaders. And so that's the thing you need to be careful with animation worklets. So here maybe we can pass a callback as parameter, which we can invoke here to call back to the JavaScript thread. And so here, maybe we're going to create a JavaScript state. So we can do GS text, set GS text, use state is, so default value empty string. We can write some text here. And so when we call back, we do set GS text of the text. And so here we could do a callback, pass the string as parameter. And you see, so we were able to call back to the JavaScript code. Now we have these animation values here, which are, you see, we write on the UI thread using the equal parameter. And we can actually do this also from the JavaScript thread. So here, instead of calling the function, I can write directly. And this is equivalent to, to using value.set in reanimated 1. So what do we have here? I can say hello. And up. So you see here, hello from Zurich. So you can read and write animation values from both the UI thread and the JavaScript thread, hence the name. This is a short introduction to worklets and shared values. So worklets are JavaScript functions that run on the UI thread in an isolated context. They can receive parameters from the JavaScript thread. They can access constants from the JavaScript thread. They can invoke synchronously other worklet functions. And they can invoke asynchronously JavaScript functions from the JavaScript thread. Shared values are animation values that can be read and written on both the UI thread and the JavaScript thread, hence the name. In the next lesson, we're gonna build gestures and animations using these worklets and shared values. When writing gestures and animations, you need 3 things. You need to create these animation values, you need to bind these animation values to gestures and animations, and you need to apply these animation values to properties of React components. And we're going to look at which hooks Reanimated 2 provides us in order to accomplish these tasks.